Hello there. This video is about half-lives. If you need some help, page 870 to 874 in your textbook will help you out. Remember, you should be taking notes during this video. If you have any time where I talk too fast, you can always hit pause and then hit play again, and I'll be right there to pick it up. Okay, let's just start by giving you the definition. A half-life is the time needed for half of the radioisotope sample to decay into products. Half-lives could be a really long time, like carbon-14, you can see in the example, is 5,730 years, or it could be really short, like our radon. It has only 3.8 days. Let's look at what this really means. Taking a look at the decay equation at the bottom, where you see potassium will decay through beta decay into calcium. So let's say potassium is represented by the red dots in the graph, and calcium is represented by the gray dots. You can see at the beginning of time we have all red dots. That's saying that we have all potassium, 100 potassium dots. After one half-life, you can see on the x-axis that we've gone through one half-life, you can see that there are half red dots and half gray dots. That means it's gone and decayed from potassium into calcium for half of those atoms. That's what a half-life is, where half of the radioisotope will decay into its products. So half of the red dots have now become gray dots. After another half-life, half of those half, so now we're looking at a quarter, there's 1/4 of the dots that are red, and then 3/4 that are gray. Half-life is the amount of time needed for half of them to decay. So we're looking at a half of a half, and after the third half-life, you're looking at a half of a half of a half. So it's much less, as you can see. Okay, what we're going to do here is take a look at how we can calculate things. I got to do it with different screens so I can write on it. There are two ways to solve half-life problems. Way number one is just keep dividing by 2. If you go through one half-life, you divide by 2 and you'll find you've got half left. So if you had 100 to start with, atoms that are radioactive, divide by 2 and then you're left with 50. If another half-life goes by, divide 50 by 2 and you get 25. So that's one way you could solve them, or you could use the equation. It's got a lot of n's in it, so it's kind of up to you if you want to use it. This big N stands for the amount remaining. So after the half-life, how much is remaining? This NO is your starting amount, the original amount. And then we're going to multiply 1/2 to the power of n. N would be the number of half-lives. Okay, so let's kind of give it a whirl with these two ways. Nitrogen-13 emits beta decay and decays to carbon-13 with a half-life of 10 minutes. This symbol right here is the symbol for half-life. Assume a starting mass of 2 grams of nitrogen-13. So the first question is, how long is 3 half-lives? Well, the first half-life takes 10 minutes. Then the second half-life is going to take 10 more minutes, so I'm going to add that up. And then we're going to take 10 more minutes for the third half-life. That's a total of 30 minutes. It takes 30 minutes for 3 half-lives to go by for our nitrogen-13. Then it asks how many grams of the isotope will be present at the end of those 3 half-lives, or 30 minutes. I'm going to do it by the divide by 2 method. At the beginning, I start with 2 grams. After the first half-life, which is 10 minutes, I now have 1 gram. Keeping with sig figs, 3 sig figs, 3 sig figs. After the second half-life, which is 10 more minutes, I now have 0.500 grams. After the third half-life, which is my next 10 minutes, I add all those up, I'm looking at 30 minutes, I now have 0.250 grams. Keeping with sig figs. And that would be my answer. Let's go a little bit trickier. In this case, we're going to have to use the equation part. Okay. So in this one, we're going to use the equation. So I'm going to write the equation. Why don't you take a second and pause it and try to do this problem without me? And then when you get stuck, or when you get to your answer, why don't you hit play again and see how I solve the problem and make sure you did it the same way. Okay. So if the passing of 25.2 years leaves 25 milligrams of strontium-90 sample, how much was present at the beginning of the half-life if the half-life of strontium-90 is 5 years? Okay, so let's fill in what we've got. My N is my starting amount. I'm sorry, my N is my remaining amount, and that happens to be 25 milligrams. So 25.0 milligrams. I want to know how much was present at the beginning. That's my starting amount, so I want to know this NO. So I'm going to multiply that by 1/2 to the n power. This n is the number of half-lives. Now they tell me that the half-life is 5 years, and they also told me that 25.2 years went by. So the question is, how many half-lives have really gone by? I'm going to do a little side part here. N is then going to be a division sort of thing. If I've got a total of 25.2 years that went by, and after 5 years you have a half-life, well, how many half-lives really happened? It's going to be about 5, but if you divide these two, you get that it's 5.04 half-lives that have gone by. If one half-life is 5 years, and we've got 25.2 years that gone by, it's about 5 half-lives, but exactly 5.04 half-lives have gone by. So I'm going to do 1/2 to the 5.04 power. I then have to push buttons in my calculator. I would take 1/2 to the 5.04 power, and then divide both sides by that. This is me writing 1/2 to the 5.04 power on both sides. And in the end, I will get 822.49 something 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 is my NO. Thinking about sig figs, these problems are kind of tricky. We're not going to get too much into sig figs, but I can see there's 3 sig figs in this number, 3 sig figs in my 25.2 half-life. We're just going to assume that's infinite sig figs, so I'm going to go 3 sig figs. 822 milligrams is my starting amount. I hope that wasn't too tricky for you, but let's try the questions and see how you do.